let's talk about the identity matrix for multiplication. And first we're going to go to the real number system. If we have real numbers, for every real number a, one a is equal to a times 1, which is equal to a. This 1 that has the property that when I multiply it on either side of an element a, it leaves it unchanged, we call it the identity element because it allows a to keep its identity. So what we need to do is ask ourselves if there is an identity for matrix multiplication. What we need here is a matrix I, we'll call it I for identity, so that when we multiply it on either side of a matrix, we get the original matrix M. In other words, M is allowed to keep its identity. In general, no, because the only way MI and IM can both be possible is if I and M are square matrices. In other words, because of the way that our matrix multiplication works, if I and M are not the same size, if the multiplication works one way and is possible, it will automatically not work when we change the order, and we won't be able to multiply the matrices. However, if I and M are both square, and if they're the same size, then at least MI and IM will both be possible, and they will give us the same size square matrix. And so it turns out for square matrices, there is such an identity that works like that. We call it I. And each particular size of square matrices will have a different identity matrix, but those identity matrices will all look very similar. They are going to have 1s on the principal diagonal and 0s everywhere else. So in the 2 by 2 case, we'll have, it'll look like that. In the 3 by 3, in other words, we're going to have 1s down the principal diagonal. Let's do a 4 by 4. Okay, those are our identity matrices. Turns out we can multiply these on either side of a matrix and it will allow it to stay the same. So let's just try that. Let's try it in the 2 by 2 case. If we have this identity matrix that has 1s down the principal diagonal and 0s everywhere else, let's multiply it by the matrix A, B, C, D like this. And first we're going to get a 2 by 2 result. And when you try it, you're going to get 1 times A plus 0 times C, which will be A. Then when we do row 1, column 2, row 1, column 2, what are we going to get? 1 times B plus 0 times D. So that'll give me B. Oops, I didn't mean to erase all that. That was dumb. Okay, so you can just visualize what's going to happen with the next one, right? When we do row 2 times the first column, we're going to get 0 times A, which is 0, and then we're going to get 1 times C, which is C, and then second row, third column, 0 times B plus 1 times D, which is D. In other words, that's the same A, B, C, D that we started with. Let's try it in the other order. In other words, if we have it coming like this, and now we're going to put the identity matrix afterward. Once again, we get a 2 by 2. If you work this out, first row, first column will give you A times 1 plus B times 0. First row, second column will give you A times 0 plus B times 1. Move to the second row, C times 1 plus D times 0, which will give me C. Then C times 0 plus D times 1 will give me D. In other words, it stayed the same. My A, B, C, D matrix stayed the same. This works for every A, B, C, and D that you could have. And if you wanted to try it out with a larger identity matrix and a larger matrix, like a 3 by 3 matrix with arbitrary letters in it for your variables, it's going to work the same way. Okay, now let's discuss inverses. Every real number except 0 has a multiplicative inverse. What do we mean by a multiplicative inverse? So that means for every real number A, there is a multiplicative inverse A to the minus 1 such that A times A inverse is the same as A inverse times A is the same as 1. This 1 here is the identity. That's our multiplicative identity in the real number system. Okay, so what is that A inverse? A inverse is equal to 1 over A, which is the reciprocal. So in the real number system, the reciprocal is the multiplicative inverse, and 0 doesn't have one. 1 over 0 would not be defined. But every real number except 0, hang on, sorry, that's very important. I need to put that in here. For every real number, not for every real number, but for every real number except 0, we have an A inverse. So that when we multiply it times our A in either order, we get the identity, which is 1. And so now we're going to do the same thing for the inverse of a square matrix. If we think of M as being our square matrix, and I is the same size identity matrix, if we can find a matrix M inverse such that M inverse times M is equal to M times M inverse is equal to the identity matrix I, then we call that thing the inverse of M. So first, let's check to see if these two matrices are inverses of one another. If they are, then I should be able to multiply them. I'll just call the first one A and the second one A inverse. We should be able to multiply them in either order and get the identity matrix. So what we're going to do is work out this multiplication. Okay, if we do row 1 times column 1, we should get 5 halves minus 3 halves, which is 2 halves. And then if we do row 1, column 2, we should get negative 15 halves. Plus 15 halves, which is what? 0, right? And then if we do row 2, column 1, we're going to get 1 half minus 1 half, which is 0. Row 2, column 2, we're going to get negative 3 halves plus 5 halves, which gives me 2 halves, which gives me my identity matrix 1, 0, 0, 1, like that. Now let's do it in the other order. Okay, I'll leave you to work out this multiplication. Work it out. You get 2 halves, 0 halves, 0 halves, 2 halves, which when we simplify is our identity matrix. Okay, so that tells me that yes, these are inverses of each other. The way you check it is you multiply them. You've got to do in both orders, and you make sure that you get the identity matrix. Now, that was one thing. Someone gave us a matrix and its inverse, and we could check, how do we come up with the inverse on our own? Here's the approach. We're going to start by creating an augmented matrix. We're going to augment our original matrix with the correct sized identity matrix. Then we're going to do row operations on it. These are the same row operations that we did when we did Gauss-Jordan elimination. We're going to do row operations until we get the identity matrix on the left. And then whatever's in the right turns out to be our inverse matrix. And if it turns out to be impossible to get the identity matrix on the left due to coming up with a 0 row, that means that particular matrix does not have an inverse. It's not invertible, and M inverse does not exist. So let's look at this one. The first thing we're going to do is we're going to augment it with the identity matrix, 2 by 2 in size. Okay. Now we want to do row operations on this. Our goal is to get the identity matrix over here, and then we're going to have 4 entries over here. This will turn out to be our inverse matrix. Okay, so we want to get it laid out like this. We're going to do it in the same way that we did Gauss-Jordan. We're going to get the 1s in a column, the 1, I should say, and then the 0s in that column. Then we move to the next column, get the 1 first, and then the 0s. And so the first thing that I want to do is to get a 1 here. So I'm going to multiply that first row by 1/2. And so that'll give me a 1, 3 halves, 1/2, and then 0. Second row stays the same. Okay, now what's my goal? By the way, is there an easier way I could have done that? Not a whole lot easier, but I could have swapped rows. That would have been fine too. But we'll go on this way since we started. Now we want to get a 0 here. So I'm going to take the opposite of that number, which is -1, multiply it by the row that has the leading one that I just created, the 1 I just put there. So we're going to do -1, row 1, add row 2, and put it back into row 2. So all this really means is I'm taking row 2 and subtracting row 1 if you just reorder this subtraction. First row stays the same. That'll be 4 minus 3 halves, which will be, 4 halves minus 3 halves, which will be 1/2. Then 0 minus 1/2 will give me -1/2 here. 1 minus 0 will give me 1. Okay, now what's my goal? Now I want to get a 1 here. So I'm going to multiply that row by 2. And so that gives me 0, 1, negative 1, 2. First row stays the same. Okay, we're almost there. Now what do I want? I want to get a 0 here. So what will I do? I will take the opposite of that number, so negative 3/2, multiply by the row with the leading 1 that I just put there, so that'll be row 2. Add it to the row I'm working with, and then back into that same row. My equivalency sign, don't forget that. Second row stays the same. Work this out, you should get 1, 0, 2, negative 3. This is where we are going to look to get our inverse function. Okay, now don't just label it on there. We want to write our answer clearly. So we will write it. M inverse is equal to the matrix 2, negative 3 across the first row, then negative 1, 2. Okay, and what you should do once you've found it, you want to make sure, multiply it times your original, see if you get the identity. If it turns out one way gave you the identity, probably that means you did your arithmetic correctly. To actually prove you did it correctly, you'd want to try it the other way also. If you're just checking for mistakes, it'll probably turn up that first one that you try. Let's do a 3 by 3. Here, we're going to write down our matrix, and then we're going to augment it with the 3 by 3 identity matrix. Like this. So the first thing that we want to do is, once again, we're trying to get the identity matrix on the left side. In other words, we want to get and then just whatever all this turns out to be. So we're looking at that left side, but when we do our row operations, we're doing them on the whole entire row, 6 entries across. So the first thing we want to look at, we want to get the 1 in a column and then the 0. So we want this to be a 1. Unfortunately, it already is. That's good. So then what do we want to do? We want to get zeros elsewhere in that column. So we want to get a 0 here and a 0 here. So both of these two, we want them to be zeros. And so that's what we're going to do next. So we take the opposite of that number, so negative 1. I'm looking at the second row. Multiply it by the row with the 1 in it. Which one? That first one that we deliberately put there, or in this case, the one that we just kept because we knew we wanted it to be there, that first row. So we're going to do negative 1 times row 1. We're going to add the row we're working with and then put it back into row 2. So my first row stays the same. And then my second row, what's really happening here, if you look at your row operation, I'm doing row 2 minus row 1. So I should get 0, 1, 0, negative 1, 1, 0. Taking my negative row 1 plus row 2, or equivalently row 2 minus row 1. Now we want to fix the third row, so we take the opposite of that number, which will be positive 1, times the row with the leading 1, so that'd be row 1, plus our row, so row 3, back into row 3. So this means we're just going to add row 1 and row 3 together, and so we should get 0, 0, 1, 1, 0, 1. Okay, so now we've got the first column done. We move to the second. So this is turning out to be not too bad because we want this to be a 1, and it already is. So once again, there's a step that we don't need to do. But we do want to get zeros elsewhere in the column. We've got a 0 in the third row, but we want to get a 0 here. So I'm going to take the opposite of that number. So I've got -1. Multiply it by the row with the leading one, so that'll be row 2. Add it to your row, which is row 1, back into row 1. So really here we're just doing row 1 and subtracting row 2, which should give me 1, 0, -1, 2, -1, 0. Second row and third row stay the same. Okay. Now what's the only thing left? We want to get a 1 here. We're moving to the third column. We're going to get the 1 and then the zeros. We've already got the 1. We want a 0 here, right? One of them's already done. But we need to get that top row. We need to get a 0 in that spot. So we take opposite of the number, so +1 times the row that has the leading one, so that'll be row 3. Add it to the row you're working with, row 1, and then back into row 1. And so we're just adding row 3 and row 1, so we get 1, 0, 0, 3, -1, 1 in my first row, and then my second row copies as is, and my third row copies as is. And so then what is my M inverse? My M inverse then is this, and that's our answer. And once again, you can verify by multiplying it times your original and making sure that you get the identity matrix. Let's try another one. Let's try this matrix. So once again, we augment it with the identity matrix. Okay, and our first goal is to get a 1 here, which we already have. And so then our next goal is to get zeros here and here. One of them's already done. We need the third row. So I'm going to do -2 times the row with the 1. So row 1, add row 3 into row 3. When you do this, you should get for your third row 0, 5, -2, and then -2, 0, 1. Our second row and our first row get copied exactly as they were before. Okay, so now our first column is done. We move to the second column. What do we want to get? We want to get a 1 here in this middle entry. How do we get a 1? We multiply that row by the reciprocal. And so that means we're going to multiply that second row by 1/2. First row stays the same. third row stays the same. Okay, so now what is my goal? Now my goal is to get a 0 in these two slots. In the second column, we get the 1 first and then the zeros. So we want these guys to become zeros. So we are going to take the opposite, so that'll be positive 1 times the row with the leading 1, so that'll be row 2, plus the row you're working with into that same place. Do the same thing with the third row, take its opposite times the row with the leading 1, add the row you're working with, and put it back into that same place. When you work out these row operations, you should end up with this. Okay, I think I got all that right. Make sure you're checking your row operations as you go along. I'm assuming you're okay with those. So now we need to get a 1 here. And so we are going to multiply that third row by 2. So that's going to give me 0, 0, 1, negative 4, negative 5, 2. First and second rows stay the same. Okay, so hopefully this is what you ended up with. We're almost there. Don't give up. Now, what do we want next? We want to get zeros here, right? So that means I'm going to do negative 1/2 times the row with the leading 1, which will be row 3. Add it to the first row, back into the first row. And then we're going to do positive 1/2 times the row with the leading 1. Add it to the second row, back into the second row. Same process as we've done before. Same process as we've done with Gauss-Jordan. When you work these out for your first row, you should get 1, 0, 0, and 3, 3, and negative 1. For your second row, you should get 0, 1, 0, then negative 2, positive 1, and your last row will stay the same as it was previously, like this. And so now we just need to write down our inverse function. Not our inverse function, but our inverse matrix, sorry, like that. And that's our answer. And once again, you could verify by multiplying it times your original and making sure that you get the identity. Let's just do one more example to show you one scenario that can occur. We're going to go back to the 2 by 2. I'll bet you're glad. We're going to augment it with the identity matrix. Like this, and then we're going to do our row operations. So I'm going to multiply to get my 1. Right here, I'm going to multiply that first row by 1/2. You could have also traded rows and then multiplied by negative 1. That'd be okay too. So if I multiply this first row by 1/2, I'm going to get a 1, a 1, a 1/2, and a 0. Second row is still here. Okay, so now we want to get a 0. So we take the opposite of that number, which is positive 1, multiply it by the row with the leading 1, add it to the row we're working with. So we really just end up adding row 1 and row 2 and putting it back into row 2. So first row is still here. Second row, 0, 0, then 1/2, and then 1. Now, what do we want to do next? We're done with the first column, so we move to the second column. So now, what we want to do is we want this to be a 1. Wait a minute, how can we turn a 0 into 1? We can't multiply by the reciprocal, because there 0 has no reciprocal. If you're thinking of trading rows, realize that's going to completely mess up that first column that you already fixed. If this happens, that means this 0 row here that is preventing us from making the left-hand side look like the identity matrix, that means that the inverse does not exist. Okay, in other words, it's impossible to get a 1 there. So that means that my inverse does not exist. And so you want to watch out for that situation and make sure you know what that means when you get a 0 row like that that is left of the vertical line. I hope this helped you to learn how to find the inverse of a matrix and verify whether two matrices are inverses of one another. Good luck, and I will see you next time.